Okay, relative maxima and minima. Right, have a look at that little table there. That's the jargon. I'm going to show you some examples down below. Okay, so and it's fairly logical. Look at this. A maximum here I've circled, it occurs at this kind of peak there. Okay, increasing from here to here, then it starts to decrease, and really that's what that's saying in that box up there. If you need to pause and read that, okay. Okay, so we're increasing, we get to a point, the maximum, then it starts to decrease, okay? And think about where the minimum is. That's this one over here, okay? A minimum right here. So this is decreasing, okay, from left to right, then it reaches a point and it starts to increase. So that point down the bottom is the minimum, up here is the maximum. And again, an open interval, like it says right here, because you can't have them both increasing and decreasing at that point, okay? So increasing to that point, okay, starts to decrease, okay? That's why we use parentheses for these solutions when it's increasing and decreasing. Right, okay, so it's just how to write the answer. I can see a point, a maximum right there. Now, of course, it's given us the coordinates, which is great, okay? So it's just how we say it. So we have a maximum, a relative maximum value of the function is 2.004, that's the y value, okay, and it occurs when x equals negative 0.082, okay, so when x equals negative 0.082, we have a maximum value at 2.004, okay. Minimum, okay, so it actually occurs at, okay, x equals 4.082, and it is negative 1.604. Okay, so just have a look how we write the answers. I mean, it's clear, you can see from the coordinates right there where it is. It's just how to write the answer. Okay? Now then, let's look at this. We've got an example. Maximizing area, floor space. Right, this, let's have a look. We have, let's say we've got an office, okay? Or the test center. There we go, some space there. And we want to kind of wall off this little area here, okay? Individual room. We've got 30 feet of divider, fencing, I think. Now, can you remember this? If one of the parts is x, okay, remember, I've just used x feet up. I have a total of 30 feet to make this little partition. And the other side must be 30 minus x, not x minus 30. Okay, I have a total of 30. If I take off the x, there it is, put it around the side there, that's why it looks like this. So, can you see that the area for this, if I write it as an area, okay, the area, it's kind of function notation, a of x. Okay, what's area? It's length times width. Okay, so it's length times width times length, doesn't matter how you write it. 30 minus x. We'll have the equation 30x minus x squared. Okay, and that's the answer. Let's have a look at the over here. There it is. Okay, right there. Okay, now then, what's another part of this? What's the domain? Well, for this, the practical domain of this is just 0 to 30, okay? Because that's all we can use, that's all the feet. Let's have a look, where are we? Right here, okay? There you go. That's the domain. What's the other final part? Using the graph, determine the dimensions that maximize the area of the floor. Well, it's right here, again, maximum, there it is. So it occurs when you have 15 feet, when x is 15. In other words, it is a square. It's 15. What's 30 take away 15? That's 15. And you realize that whenever you're maximizing the best thing is an actual square over the rectangle shape. So that occurs at x equals 15. What is it? It's 225, because 15 times 15 is 225. Okay? So determine the dimensions that maximize the area. It's 15 by 15. I'll show you a little bit ahead. Okay? I'm going to show you something right here. 1 second. Right. Now, it's also the vertex. Alright, now this is for later, but look at this. To find the x value of the maximum, okay, we use negative b over 2a. Negative b over 2a based on this as the equation. Okay, so let's go back to this. So, a is negative 1. Remember, x squared first. Okay, x squared first. B is 30. Okay, so that's B, and that's A, unfortunately. A and B. Now I'm just jumping ahead here. I mean, obviously this is showing you graphically that it's 15. Okay, it's there. Right, so if I do this, negative b over 2 lots of a, negative b, that's negative 30, over 2 lots of a, which is negative 2. What's that? That's 15. There you go. Now that's for later, a little shortcut, okay? But anyway, that's just you using maximum to kind of just do a little practical application, okay?